Hi students, this is AJ sir. Let's study 9th standard ICSE Math, exercise 7B. Now in exercise 7B, question 1 is solve for x. That means find the value of x. Now on LHS and RHS, if the bases are same, that is 2 and 2, then we can compare the exponents. So the way we'll solve it is like this. First of all, 4 is 2 squared. And if you multiply these, since the bases are same, you can add the indices. So it becomes 2 plus 3x plus 1. And now we have just one term on LHS and RHS. So now we can definitely compare the exponents since the bases are same. That means this is equal to this because the bases are same and there is only one base each. So I don't want two bases. Now 2 plus 1 is 3. 3x goes and becomes minus 3x. Minus 1 goes here and becomes plus 1. And ta-da! X is equal to 2 is the answer. Similarly, let's solve Roman number 4. Clearly 49 and 343 are powers of 7. So we can easily convert them into 7 square and 7 cube each. Now the powers are multiplied here, so that's distributive multiplication, I get this. And even here, distributive multiplication, I get 3x plus 3. Since there is a multiplication sign here and the bases are same, so I can add 2 to the powers. So on the LHS and RHS, only one base each, so I can easily compare the exponents part. 3 plus 2 is 5, by the way. So we get this equation, get x's together, get numbers together, and get the value of x. Even in question number 2.2, we just have to solve and get the value of x. Now the moment we see a root sign, we know that that is nothing but the power half. So the root sign becomes power half. And now we can multiply these two powers. It becomes x plus 3 upon 2. On the right hand side, on the other hand, again I get the base 2. So we have the same bases. That's nice. Now we can equalize the powers and solve and get the value of x as 5. Now 2.4, mark it as IMP. This one. Again, I see a root sign, and the moment I see a root sign, and this time it's a cube root. So I'm going to write the power 1 upon 3. So this will be multiplied with the other exponent, x minus 1. Make sure you write the brackets. So this will become x minus 1 upon 3. But on the right hand side, this is a perfect cube. However, to equalize the powers, the bases should be same. In order to make the bases same, I'm going to reciprocate this. But if I do that, I will have to change the sign of the power. That's okay. Now at least I can equalize the exponents since the bases are now same. And then solve it like an algebraic sum. You get the value of x as minus 8. Now mark 3.2 as an IMP sum. I see that there is a ratio here. Ratio means division. So first let's write it in the ratio form and then we'll find the value of x. So numerator upon denominator is equal to numerator upon denominator in the fraction form. Since the bases are same, division means subtraction of the powers. So this becomes x squared minus x. And this is also a perfect square. Now LHS, RHS have the same base. So the exponents are equal. This is a quadratic equation. So we'll have to do splitting the middle term. I want the middle term as minus 1, but the product of the two terms should be minus 2. So I reckon it is minus 2x plus 1x. Check. Minus 2x plus 1x is nothing but minus x. And minus 2 into 1 is minus 2. So this satisfies the equation, the conditions. I got 4 terms is equal to 0. Take the first two terms in one pair, take it out common, x. What is left? X minus 2 is left in the brackets. Here nothing is common, so take out 1 as common. What is left in the brackets? X minus 2. Obviously the brackets have to be the same. Now take out the brackets common out, and in the other bracket what is left? X plus 1 is equal to 0. When the product of two brackets is 0, that means at least one of them is definitely 0. So either this is 0 or this is 0, or maybe both. So if this is equal to 0, shift minus 2 here, it becomes plus 2. So that's one value of x. And if x plus 1 is equal to 0, shift plus 1 to the RHS, it becomes minus 1. That's another value of x. So here we got two answers for x. Next, mark question 4.2 as IMP. Now, I see there are three terms here, 1, 2 and 3, which makes this sum a little more advanced than the previous ones. So what we'll do first is x 2 raised to 2x, I'm going to write it as 2 raised to x the whole squared. If I multiply the powers, I get back this term, so I'm just rearranging it. And here there is an addition of the power, so let's split it into two different numbers, 2 raised to x into 2 squared. So x plus 2 were separated. And these are pure numbers, so just find the value, which is 32. Now I see that I see a 2 raised to x here as well as a 2 raised to x here. So I'm going to assume this as a. Because by doing this, I am converting this into the format a squared plus 4 into a. 4 is 2 squared, by the way. Minus 32 is equal to 0. So this is a quadratic equation which is manageable. Now I have to split this 4a, the middle term, into two parts. So I'm going to split it into 8 minus 4, because 8 minus 4 is plus 4. Also 8 into minus 4 is minus 32. So it is satisfying both the conditions. That is, the middle term should be split into two parts, but the product should be equal to the constant into the coefficient, whereas the coefficient here is 1. So by doing this now, the first two terms have a in common, so take it out common and a bracket is left. And in these two terms, minus 4 is common, so take it out and in brackets a plus 8 is left. The sign has changed because minus was taken out common. Clearly, the two brackets are the same, so take it out common. And in the other bracket, what is left is a minus 4. So again, product of two brackets is coming out to be 0, and we know what to do in such a case. Either this bracket is 0 or this one. I have directly written the answer because I calculated mentally that if a plus 8 is equal to 0, then a is equal to minus 8. Or if a minus 4 is equal to 0, then a is equal to 4, shifting it on the other side. Now resubstituting here, so let me write here, resubstituting. It is necessary to write these statements. So I get 2 raised to x is equal to minus 8 or 2 raised to x is equal to 4. Now this is an impossibility. 2 raised to any number cannot give me a negative answer. It's not possible. In fact, if I do 2 raised to minus 3, then the minus simply means it will be reciprocal. It doesn't mean the answer will be negative. But here 4 is nothing but 2 squared. So now the bases are same, so the exponents can be equalized. So the answer becomes x is equal to 2. Now in the fifth sum, we have this equal to this equal to this. So we have two equations actually. This term, first term is equal to the third term, and also second term is equal to the third term. Third term is purely a number. In the first term we have m, and in the second term we have n. So we have to find the values of m and n. So right, let's write the two equations separately, the n equation and the m equation. And now we'll simply solve them to get the values of m and n. Here our aim is that the bases on LHS, RHS should be the same so that the powers can be compared. I see a cube root and I wrote 1 upon 3. I see a square root and I wrote 1 upon 2, which got cut. Here also 3 1s are 3 2s are. Now 16 is 2 raised to 4 into minus 2 upon n, and here 8 is 2 cube. So now I can compare the exponents part. So we get 4 into minus 2 minus 8 upon n is equal to 3. Cross multiply and get the value of n. Now let's solve for m. Square root, so again it will be 2 upon 2. 8 is 2 cube. This got cut, so this disappeared, but 8 is 2 cube. The powers can now be equalized and get the value of m. Next, the sixth sum. Mark it as IMP. It's a beautiful sum. I got two equations. So let's simplify it and then we'll solve it further. By the look of it, I feel that since we have two variables and two equations, this will ultimately become a simultaneous equations sum. Let's attack the first sum. Now if you notice, this is a division sign, okay? Be very careful. It is not a plus sign if you look closely in the textbook. Now square root means upon 2 in the power. In fact, 32 is 2 raised to 5. Division, so I'm writing it like this, equal to 1, of course. So 32 is 2 raised to 5, so the power changes. Now the bases are same, so division becomes subtraction of the powers. What I would do is, on the right hand side, I will write 1 as 2 raised to 0. You know, anything raised to 0 is 1. The reason why I'm doing this is so that the basis on LHS and RHS is exactly the same. I could have very well used 3 raised to 0 or 4 raised to 0 also in some other sum. If the bases are same, that is 2 and 2, now I can compare the powers. So this is equal to 0. That's how I got my first equation in x and y. Now let's attack the second equation given in the question. 8 is 2 cube minus the term, so send it on the RHS, so it becomes a positive term. 16 is 2 raised to 4, which has to be multiplied with the power which is already given, so use brackets. So LHS, RHS have the same base, 2 and 2, so the powers can now be compared. They are equal, and open the brackets. In fact, I sent 4 down here, minus x upon 2 sent on the other side. Multiply the whole equation by 4, or you can take an LCM. I am getting the second equation in x and y. So I got two equations in x and y. Solve them simultaneously. I'm not going to do that. You have to do that. Show all the steps and get the answer as x is equal to 2 and y is equal to 4. Next question, 7.2 is a proving sum. Proving sums are ideally very easy. We started the LHS. I cannot see any kind of formula here, so we'll simply open the brackets. Distributive multiplication here, here, here and here. So we get this. Next, division means multiplication with the reciprocal, and multiplication, since the bases are same, just add the powers. Now I see that minus AC plus AC gone, this gone, this gone, and AB is left in numerator and denominator, and the terms get cancelled, and the answer is 1, which is equal to RHS, hence proved. Now 10th sum, mark it as IMP. This sum looks so delicious. What is given and what is asked, you can't see any connection at first glance. It seems like a sum without any head or tail. One thing we can notice is something special about the numbers, at least 5, 4 and 20. I know that 20 is equal to 4 into 5. So if I start with that equation, 20 is equal to 4 into 5. And if I can substitute the values of 20, 4 and 5 in terms of PQR, we should be able to reach this equation. So this sum requires that kind of manipulation. Now you may wonder, why are we solving such sums? How is it useful practically? Well, when you solve these puzzles and riddles on WhatsApp, that time you never ask yourself why you are solving them and spending so many hours every day. Because it's fun, right? So consider this also as fun. So let's begin. we shall assume these terms equal to k, so that this is equal to k, this is equal to k, and this is equal to k respectively. The reason we are doing this is because now we can shift the power to the other side. Minus p will become minus 1 upon p. Let me give you an example here. If I say that x squared is equal to, let's say, 4. So what is the value of x now? 2 goes here and becomes square root of 4. Or you can simply say that 2 goes here and becomes 4 raised to half, because half is nothing but square root. Or if I say x cube is equal to 8, I can also write it like this. 3 goes here and becomes 1/3. So x is equal to 8 raised to 1 upon 3. That is cube root of 8. Similarly here, minus p went on the right hand side and now it became minus 1 upon p, the reciprocal. Just like 2 became half and 3 became 1 upon 3. And if it was minus 3 out here, it will become minus 1 upon 3. The negative sign will remain as it is. Yes, I know ideally if there is a negative power, we do the reciprocal so that the power goes down and becomes positive, but no need to do anything like that in this sum. We will just shift minus q on the other side and it will become k raised to minus 1 upon q, and r on the other side to become 1 upon r. The reason we are doing this is because now I have the values of 5, 4 and 20, which is what I wanted, if you remember, because we started off with the equation 20 is equal to 4 into 5. Now substitute the values of 20, 4 and 5 in terms of k. It's good that the bases are same. There's a multiplication here, so get the powers together, addition, that is minus 1 upon q minus 1 upon p. Again, LHS, RHS bases are same, so now I can equalize the entire powers. I get this equation and rearrange the terms to get what is asked. So how will you remember that this is how we have to solve this sum? How will it strike you during exam? Well, that's the whole reason why we practice math. You'll do the sum now. It's an IMP sum, so you'll do it later again and again, and you'll remember how to do it. And if a different sum of this kind is asked, you will be able to remember the technique and apply it in any other sum. That's how you're developing your IQ and using your brain cells, which otherwise used only for entertainment will get rusted. Now the 12th sum, this equation is given. We can easily solve this to get the value of x. Then we will substitute it here to get the value of the expression given. So since 25 is a perfect square, write 5 squared, the powers will be multiplied. Now that the bases are same, we can equalize the powers, solve and get the value of x. And then, as I said, substitute it in the equation given, 5 here and 5 here. So I get this. 3 squared is 9 and 2 raised to minus 2 will be reciprocal. So it will become 1 upon, this will become 1 upon 2 squared, that is 1 upon 4. So the answer is 9 upon 4, that is 1 upon 4. Next, 14.2. Solve and get the value of x. I see that the bases are all a, but on the LHS I see that there are 2 terms, if I can call them terms. But to compare, I should have only 1 term on each side. So let's combine them. The powers need to be multiplied, so I'm just writing it with brackets here. There's a multiplication sign and the bases are same. Good. So this is 4x actually. So that will be added, because when there is multiplication between 2 terms, the powers are added since the base is same. The RHS remains as it is, but now that both the bases are exactly the same, the powers can be equalized. This is algebra, get the value of x. Next, 14.4, mark it as IMP. I see 2, 2, but 48 is not a perfect power of 2. That's a bit strange. So how should we solve this? Perhaps we should split the powers. Maybe it should be 2 raised to 3x into 2 raised to 3 even here. Then should we try to make it into a quadratic equation? Let's solve and find out. So I've split them into 2 raised to 3x and 2 raised to 3. Similarly, I've split them also into 2 raised to 3x into 2 raised to 1. And I've shifted this to the left hand side. So this becomes minus here. 48 remains on the right hand side. Now I see that 2 raised to 3x is common between these two terms. So let's take it out common, and what is left is in brackets. What is left? 2 cubed, that is 8, minus 2 is left. And that is 6. And 6 goes down, and 48 upon 6 is 8. Now that's a perfect cube. Since the bases are same, now the exponents can be compared and the answer comes out to be x is equal to 1. So there was no need for quadratic equation or anything complicated here. And now finally 14.5. This seems to be like a similar sum. So first of all, open the brackets. So 3 into this and 3 into 1 is 3. This, I guess we'll have to split it into two terms, that is 2 raised to x and 2 squared plus 5. Well, 3 plus 5 is 8, and send the 8 on the other side, so it becomes minus 8. So all the numbers on the right hand side, please. Now here I see 2 raised to x is common, so take it out common. So what is left in brackets? 3 is left, minus 4 is left. 3 minus 4 is minus 1. Minus 1, there's a multiplication here, so minus 1 goes down, division. Minus minus cut. So what is left is 8 on the RHS. So 2 raised to x is equal to 2 cube. Therefore x is equal to 3 is the answer.